Another question.
Yes.
For the second option, would that also include the other person that you guys asked, they will not be to you, or are they allowed to teach you?
Oh, that's a good question. I don't know. I guess they'd still be able to speak to you, but you can like not speak to them. I don't know. Like you would like try to, but nothing would come out type thing. I don't know. These are hypotheticals. I feel like no type of communication. Like you would try to, but it would be like gibberish. I don't know. I'm just thinking in my mind that some unknown force would just stop you from trying.
Some unknown force specifically taking you alone and just screwing.
I guess. Alrighty, let's go over these. We need to distribute in order to simplify. So for number 1, distribute the 5 to everything there. You get 10x minus 15 plus 7. And then combine any like terms. Negative 15 and positive 7 give us negative 8. 10x minus 8 was the answer to the first one. If you guys are cold or can't hear, you can turn that off or turn it to face someone else. It just gets hot in here sometimes. Yep. There you go. For number 2, same thing, we need to distribute this 0.2. You could have done this in your calculator. Also, if you're doing it by hand, I like to think of them as whole numbers and then add the decimal back in. So, like, this would be 0.2b. If this was just 2, 2 times 10 is 20. So 0.2 times 10 would be just 2 by removing that decimal. And then I'm just going to bring everything else down. I have 2 sets of like terms, the d's, the numbers, the constants. 0.2 minus 0.9 would give me negative 0.7. And 2 plus 3 would give me 5. Theo, can you put your phone back? Can you put your phone back? Make sure you put your phone back. And turn this sound off. For this last one, it looks a little confusing, but really we're only distributing once. I actually dropped off the parentheses because in front of this is really a 1. But if I multiply this by 1 and this by 1, nothing changes. So I could really just drop those parentheses. I'm really just distributing this. Remember the negative 1 here to these 2 numbers. So x minus 2 minus 3 plus x. 2 negatives make a positive. And then combine our like terms. So x and x give us 2x, negative 2, and negative 3 give us negative. Questions about any of those? Take out your evaluating expression notes if you don't have them out already. If you need another one, let me know. I have extras. We're going to jump to this one. I know we didn't do all of the ones on this page. You may have, but look for this one. Right, remember that when we evaluate, we're taking that number, we're putting it in wherever the variable is. So if I put that in, and I don't think I said this before, but use parentheses anytime you put a number in for a variable, that way you know it's like a placeholder. let's say you had something like this where you had to square a fraction. You would need to square both the numerator and the denominator. What is 1 squared? 1. And what is 2 squared?
4.
4. So when you square a fraction, you have to square both parts. Or if you raise any fraction to any exponent, you're doing it to both parts. Now that that exponent is gone, you can multiply these two and add those two numbers together. You could do this on your calculator. I'm going to do this by hand. If I wanted to add this fraction to this whole number, remember that all whole numbers are really fractions over 1. If I wanted to combine these fractions, they would need to have the same denominator. So I would need to make this 4. The only way to do that is to multiply it by 4. And what I do to one part of the fraction, I have to do to the other. Now they both have the same denominator, so I can add them together. Add just the numerators together to get 7, which is the same as 1 3/4. Shanna, if you want to move up here, you can. Okay, thank you. Do you have any questions
How
on
do you,
that?
what is the multiplying thing by 4?
Say that one more time.
What, I don't understand how you multiply 1 over 1 by, because it's the same thing.
This part.
Yes.
Okay. So anytime you have a fraction, so this one is this, right? I need to change this to a fraction. All whole numbers really are fractions. They have ones underneath. In order to add these fractions together, these need to be the same. The only way these are going to be the same is if I change this to be 4. I can't just write in a 4. The only way this would become 4 is if I multiplied it by 4. This would change it to 4, but I can't just change one piece of the fraction. I have to do it to all parts, the numerator and the denominator. Which is why that changed to 4 over 4. Does that make more sense? Did that answer your question?
Yes.
Okay. Jenna.
The power of 2 play.
So here what we really did was this. We took this fraction and instead of writing it out like this, we just squared both numbers. So when you see a fraction squared, you're thinking this, you're squaring both of those numbers. Does that make sense? No. This is really a squared times 3. It's not 3 squared and a squared. If they were both in parentheses, then it would be. I believe we touched on this one. I'm going to skip this one, jump down to this one. So we can do it by hand so you see what that would look like. We now have 2 variables and we're given 2 different values to evaluate with, which means we need to put both of them in where A equals 4 and B equals 6. I'm going to rewrite this with both of those in there. 4 times 4 minus 3 times 6. Once you put those numbers in there, it's just order of operations. What do you do first? And go from there. Yes.
Still not put the like actual sign, sign in the.
So I could have put 4 times 4 and 3 times 6, like the dot. I could have did that. The parentheses mean the same thing. But when you're evaluating, you should be using parentheses to show it's a placeholder. But they mean the same thing. This is a set of grouping. I need to do everything inside here first. I see that I need to subtract, but I need to figure out what 4 times 4 and 3 times 6 or 93 is first. So multiply each one, figure out what those are. Then I can subtract on the inside. Remember that absolute value measures distance. So once there are no more operations, you can mathematically change that to a positive number. And this is saying this is 2 away from 0. And then continue to simplify. Negative 2 times 2 is negative 4. Negative 4 plus 5 is 1. So anytime there's no more operations after you're done, it can just go positive, no matter what it is. Yeah.
The answer would be negative 4 plus 5.
Simplify that. It's 1. Yeah. We went over some parts of it. Not that question exactly, but. Any other questions on that one before we move to the next one? Yeah, I'll sign you one. The next one that has the square root, it's the same process. We just end up putting 64 underneath the square root. This would be 2 plus the square root of 64. What is the square root of 64? Felix. 8. The one next to it now has a cube root, so that it looks like a square root, but there's a 3 on the outside. It's not a square root, it actually means the cube root. This means, so let's go. Square root of 64 is 8, because 8 times 8 will give us 64. When we talk about cube roots, I'm just going to put it in a random example. We're looking for something that multiplies by itself 3 times. For this one, what would it be? 3. Would 3 times 3 times 3 give us 8?
Wait, no, I thought it was 27.
For 27, yes, that would be the answer. For 8, what would that be? So for 27, you are exactly right. So if I put in 27 here, the number that multiplies by itself 3 times would be 3. 3 times 3 is 9, times 3 again is 27. So our final answer would be 0. Yes, I know. Over which part? The cube root one. Do you get lost or confused about something?
No.
At which part?
The little thing.
The cube root of 27. So we're looking for some number that multiplies to be 27, but it has to be the same number 3 times. So you could try this if you're not sure. 1 times 1 times 1 is just 1. 2 times 2 times 2 is 8. 3 times 3 times 3 would give us that 27. So that's how we got that 3. This? This too? We haven't done this yet. I was just writing it as So let's actually do that. That way it's less confusing. Right, this last one has a cube root and with one variable and something else with a different variable. Hold that thought. So we're going to put 27 underneath the cube root. We kind of already know that answer is going to be 3, so we just did that. Then we're going to put 1 in for y. So we have 2 times the cube root of 27 minus 3 times 1. When you have numbers being multiplied to or added to whatever to square root and cube root, it might help you to put parentheses there. That way you can separate them. We know this is 3. That's 3. 3 times 3 is 6. So our final answer would be Do we have any questions on how we evaluate instructions? So I'm going to give you guys like 15, you may not even need that long, minutes to work through any problem we didn't do here and the back. The back of this that looks like the front, not the back. Okay. Work with the people around you. Ask questions. Get help. If you get stuck at anything, let me know. As you're working and get to problems where you need to put the fraction in and need to know how to do that, or the exponents, or the absolute value, the square root, the cube root into that calculator, let me know and I'll be around to show you that. And then if you have questions, let me know as well. I am going to quickly show you the answers, check your work, and then if you have questions on any of them, we can go over them. So, negative 60, negative 6, negative 25, I would say like put a star by any you have the question mark. Negative 13, 27, 3, 10, 1, 3, negative 7, 13, negative 1, 4. Do I need to go back to any? Stella? That first one? One? That one? I need to go back to any others. Second to last. I should have really numbered these. I don't know why I did. I can go back to the first page if you need to check any of those. I need to do number 6. That's the one. You need to fill out. Huh? Right. Do we have questions on any of those? So, tell me what it says.
4a squared plus a squared.
Oh, I see what Lily. Yeah, I'll scan you out. Huh? I'll scan you out. Questions on any others? In October. Questions on any others? Jenna. The key verbs. Hold on one second. So for any problem you have with the key verb, you need to be thinking, what number can I multiply by itself 3 times to get 8 or whatever? So if I'm looking for 8, if I multiply 1 times 1 times 1, will it give you 8, Jenna? If I multiply 2 times 2 times 2, will that give you 8? So when you put 8 in, you get 2. Other questions on any of these? So if you were putting this into your calculator, make sure that the exponent was outside. If you put this inside, this became -1 times 3 squared, which is not the same thing. Do not put your exponent inside the parentheses because you will get the wrong answer. You will get a negative answer instead of a positive, which means. Any others?
Um, 4a squared plus 2.
So with this one, you need to square your fraction first. So this would become 4 times 1 over 4. 4 times 1/4. This should look familiar as that multiplicative inverse.
Oh.
Which gives you that. Okay. The paper I just passed out is your review for your test. That is next class. I did not pass any to your paper. I thought I did, but I think I was coming back and then I got sidetracked. So next class. So today is Thursday, so Monday, yes. So I am giving you guys the test on Go Formative. So you guys need to bring your computers to school on Monday. There will be questions where you need to show your work, but you will have the option to just write that out on paper and either take a picture of that with your computer or hand that in to me. So you won't need to actually show your work like in Go Formative.
Are we allowed to use a calculator for any like complex fraction work?
So I'm gonna allow you guys to use Desmos on the test. There will be actually a Desmos calculator on the test. On not the translating one because you don't need that. The simplifying and evaluating one, you'll have the Desmos calculator in Go Formative already. Yes, I'll sign you up. So I will send out a reminder to remind you to bring your computers to school on Monday. Nope, I was definitely about to put in my own name. We're about to do some of it right now, then you'll have the rest of class to work on others. And then before we take the test on Monday, we'll ask and go over any remaining questions we have.
Are we gonna finish this project first?
The last page is strictly for your practice. So we're going to go through some of these. There are 3 objectives on the test. Translating expressions, so remember that was taking words, putting them into expressions, and vice versa. Simplifying expressions, so that's all the combining like terms and distributing we've been doing. And evaluating expressions, what we just finished doing today. So, to kind of go through some of those, we're not going to go through all of this together because I want you to have time to work through some of this. Really quickly, we're going to go through these words and you're going to tell me, is it adding, subtracting, multiplication, or division? Sum. Product. I'm just going to put the dot. Decrease by. Subtracting. I was like, I heard things, but wasn't sure. Quotient. Increase by. Difference. More than. Less than. And that's a turnaround phrase. Twice something. Multiplication. Okay. We're going to jump down to number 17. We need to write a verbal expression for this algebraic expression. Someone tell me what words you come up with, Jenna.
The sum of a number and the number multiplied by 1/2.
We're going to switch that just a little bit. Start off with 1/2 multiplied by, or 1/2 times. And then we can say the sum of, since these are 2 different numbers, we can say a number and a different number, or we can say x and y, however you want to write that. But anytime you have 2 different variables, you have to specify that they're different. You either say exactly what they are, the variables, or say a number and a different number. Because if you just say a number and another number, well, another would work. If you just say and a number, it kind of means the same thing.
We also like if we said 1/2 multiplied by a number and
Sure, that would work. You could specify one and not the other. The other ones were simpler, so that's why I didn't try that one lower. Jumping down to number 20. 8 less than a number. How would I write that? I heard 8 minus n. X1. But it would be x minus 8. Remember that less than means 8 goes at the end. Again, a lot of these were easier ones. After we go through the ones we want to after we go through the ones I want you to go through, if I can talk today. If you see one that maybe the whole group would benefit from, and you had a question about, you can go through those as well. Jumping down to 34. The cube of A plus B. How would I write that? Priscilla. I mean, also. Say that one more time. Because it's addition and you can put it either way. Number 35, the cube of the sum of A and B. Felix. So how would I show all together that it's cubed?
parentheses the cube over the.
Add parentheses. So notice that these two things are different. One is saying the cube of just one and adding something else. The other is saying I'm adding both and taking the cube of both. So translating. Can you do it from words? Can you do it from expressions? Next page. Some of these might be the same problems we just did, and that's okay. Starting with number 2. If I put 81 in here, all right. The square root of 81 is what?
We
don't have that page.
That's
We only have these
interesting.
2 pages.
I can say some of that.
Huh. No. Okay, the whole thing got messed up, got it. So, okay, let's just go to that last page, this one. You guys have this page. I don't know why it does print it off like that. Anyway. Alright, let's see. Square root, cube root, fraction, exponent, cube root, absolute value. Absolute value. Square root, cube root. We'll do this. Okay, start over. Okay. For number 12, and again, we may have done this one already, but that's alright. Put 4 in for B, I'm sorry, for A. 6 in for B, they switched the letters to be mindful of that. That might happen. The very last page on the back, yeah. It's alright. And simplify, that would give you 24 minus 12. Yes.
The minus sign.
Not till the end. You don't change anything until the end, when there's nothing else left. 24 minus 12 is 12. This is already positive, so I'm just going to bring it out to get positive 7. With evaluating, the trickiest ones are going to be the absolute value, remembering at the end, make it positive. Your exponents, making sure it's not in your parentheses, and doing your square cubes. I'll send you that. Number 14, put 64 in for the square root of x. The square root of 64 is 88. So this would give us 10. I vaguely remember doing that one. My brain is like all over the place, so sometimes I don't even remember what class we're in. Number 15, put in the cube root of 27. The cube root of 27 is 3. No, we did that one. Did the last one? Yeah. 15.
Yeah.
So we're looking for the cube root, not the square root of 27. So what number times itself 3 times would give us that number? And then same thing, put in your figure 27. We just found the figure 27 is 3. And we did this one. So with evaluating, basically make sure you're putting it in carefully and using the correct symbols. Jenna? Is that one we did? Okay. Let's come back to that one and then yeah. Just put a star by that so we know to come back. Now I don't know what you guys have and don't have. Okay. But it's a certain one. This one? Yeah. Because I have this page and this page. We're just going to do a couple. Really, you just need to be able to go back and forth. Being able to model them. This is part of the simplifying expressions. These are a little different because they have X and Y. So if you get some problem that has a key, make sure you pay attention to the key. And then if it says like something like this, anything shaded would be the negative. Now, each key you see may be different, so keep that in mind. This one is different than one we used before. But if I were to model 4x squared plus 2xy minus 3y squared, how would I do that? Using this key. Four x squared using this key. How would I represent that part? Would I use a bigger square, the rectangle, or the small square? I heard the biggest square. What did you say after that? Four of them. If I had to represent 2xy, which of these would I use? Vanessa. The positive or the negative? The non-shaded one. If I had to represent negative 3y squared, how would I represent that? Which ones would I use? Small, shaded. And how many are those? So you may see something where you're given this key and have to make that, or you're given the key, given the blocks, and have to write out what the opposite would be. We're just going to do one more of those and then move on to the next. Negative 3x squared, how would I represent that? Caleb? Doesn't have to be completely shaded. As long as I can tell that it's not unshaded. Negative xy. How would we represent that? Felix.
One of the shaded.
Correct. Positive 2y squared. Kayla. So part of your simplifying expressions, can you also model them if giving a key? I have 2 pages of simplifying, but I don't have one. I have not that one. This one. You guys have this. We're gonna do a couple of these and then write out a couple. So on the simplifying page, and I don't know why they stapled them like that. Usually they just staple them at the top. You gotta maybe copy it. For number 2, how would I start this? Distribute it. I'm gonna do it at the same time. 5 to everything there. Negative 6 to everything here. Then what? How would I simplify this further? Combine your like terms. What are those like terms?
The 5y minus
5y minus 6y, which would give us how many y's? There's 2 different answers. There should be negative 1y or just negative y. And then negative 5 minus 36 would give us, Felix? Okay. So with all of your simplifying problems, if you can distribute, distribute. If you have like terms, combine them. Remember that different variables are not like terms. Variables with exponents and variables without exponents are not like terms. So like number 7, let's try that one. First, can we combine any like terms inside the parentheses?
Yes.
I see yes, I heard yes, and I see no. No, because we have 2 A's, but one has an exponent, one does not. So those are not like terms. We can distribute though. We have negative 18A plus 54 minus 54 squared. Do we have any like terms? Felix. So because those are our only like terms, I'm going to rearrange this and combine them at the same time. Remember that if you have a term with an exponent, that goes first. Negative 18 minus 7 would give us negative 25. And then I would put the 54 at the end. For this test, are you going to get marked wrong if it's in the wrong order? No, but I'll let you know. Hey, remember that it goes in the other order. Moving forward, that would happen. Yeah, no.
Oh, never mind. I saw it wrong.
At either the bottom of your paper or wherever you have space, I want you to write down this problem. I'll read it off to you. This is number 10. 1/9, then in parentheses, 18x minus 9, in parentheses, minus 1/7 then in parentheses, negative 21x plus 14. In parentheses.
Will this problem be on the test? Will this problem be on the test?
This one exactly? No. One like it? Yes. Yes.
Questions on that?
On each section,
Just like the whole.
so there are 3 objectives. Each objective has its own test grade. There should be no more than 6 questions on each section. So 18 total, but like 6 on each.
So it's like 3 different questions.
Yeah. So you'll see 3 test grades when it gets graded.
So I can agree with like up here is like each section.
Say that one more time. Can you retake it? We'll talk about that afterwards, but yeah. Okay. Same process. Distribute. Even when you get fractions, so this part is not new because we've done problems like this before. Distribute it just like you would any other. Most of the fractions you see should be able to simplify with the numbers you're given. Also remember that if you have a fraction like 1/9, instead of thinking about it as 18 times 1/9, think about it as 18 divided by 9. Then it might be easier. 18x divided by 9 would give us 2x. Negative 9 divided by 9 is negative 1. Negative 21 divided by negative 7 would be positive 3x. 14 divided by negative 7 would be negative 2. Most, if not all of the time you see fractions like this, they'll simplify to easier, nicer numbers. So you might get a problem that has fractions twice. You might get a problem that just has fractions once. It doesn't matter. The process is the same. Don't let that freak you out if you see that. And yes, babe.
Remember like
This negative is really a negative 1. So you're putting negative 1 to go. In the next 4 minutes, what other problems did you see that you had questions on that you want to get those answered before you try on your own? 29 on the 15th. 29 on the 15th. Twice the product of A and B. How would I write that? If it's twice the product.
oh,
That you could also just do this because you're multiplying everything together. Multiplication is commutative. The order in which you put it doesn't matter. The sum of 3 times A and B. So I'm adding these 2 things together, but I'm also multiplying these 2 things together. How would I write this? What 2 things am I adding together? Which two things are we adding together? B is one of the things we're adding. What is the other? A and B is one of the things we're adding together, but not just A. 3. And we're doing what to 3 and A? So I'm putting them together. One half the product of X and Y. This one's very similar to this one, except it has that fraction.
Did you X plus Y versus?
For that one? No. Because it's product, not sum. Yes.
Number 32. We put 3.
No. Because A needs to be multiplied to 3. All of that is being added to B. Bella. Twice a number increased by 3 times the number. This one does not say that these numbers are different numbers. So whatever variable we choose here is going to be the same variable over there. Twice a number, how would I write that? 2 times x and whatever. And then increase by, how would I do that? Add 3 times the number. How would I write that? 3 is whatever variable you chose. It doesn't say to simplify it, but we know those are like terms we could simplify it. Okay? Now, the rest of this is not homework, but what I'm going to say is do what you feel like you need to practice before Monday. There is the Evaluating Khan Academy that is due tomorrow night. Make sure you do that. There's also the Delta Math practice that is due by next class. Next class, we're going to go over any questions you have on Delta Math Khan Academy, this review, and then you guys are going to take your test. Yeah.
When a negative number is multiplied squared, does it turn positive?
But this, they're all multiplied. Yes. Make sure you put the calculators on.